So welcome back after a long time. So have you heard about this corrosion, sulfidation corrosion? It's the most dangerous corrosion which gives the pure thinning and leads to the rupture of the equipment or piping. So we'll see how this occurs, where how which part of the plant is affected, how we can prevent this. So let's start. Stay till end of this lecture to know more about this. So first of all, we will understand the introduction and mechanism of the sulfidation. So sulfidation is a corrosion which occurs in carbon steel and other alloys resulting from their reaction with sulfur compound. So metal directly react with the sulfur compound. Here you can see the mechanism, the sulfur containing gas or hydrocarbon which having the sulfur, they get react with the outer metal surface, and the first is due to the gas diffusion. The gas will diffuse to the hydrogen and form hydrogen sulfide gas or reactive sulfur will which is present in the stream will react at a temperature mainly 230 and is more effective at temperature 260. So there is will be a chemical reaction of metal with the sulfur and it will form the metal sulfide. You can see here, and once the one layer of metal sulfide get forms, it becomes unstable. Then the sulfur penetrates deeper and it's make another layer of metal sulfide, another layer of metal sulfide. So due to the diffusion and further the reaction of sulfur with metal, this layer one by one they are unstable layers and they will corrode and will cause the sulfidation corrosion. So the chemical reaction, the sulfur atom react with iron and releasing the hydrogen and form the iron sulfide. This iron sulfide which get forms is not stable and there is a growth of that scale, and a porous black layer of iron sulfide grows. This is a protective oxide which is not which further penetrates the base metal. So this, due to this layer by layer corrosion of the metal, this uh, occurs a uniform thinning and the reduction of wall loss. So you can see here, this is our this is the sulfurous environment, and this is our metal, and this sulfur penetrates into the metal and form metal oxide. So the metal affected materials which are the affected. So basically carbon steel are the most affected material. Then low alloy steels having some better resistant, but these are also having effect of this sulfidation. Then 400 stainless steel and then 300 stainless steel. In order to, so this is the most susceptible, lesser and least susceptible. So nickel base alloys are often affected to varying degree of depending on the composition. So nickel alloys are also affected, and copper based alloys form sulfide corrosion products at lower temperature than carbon steel. So these copper alloys are much more susceptible in sulfurous environment. That's why these are not recommended. Now, what are the contributing factors which is causing this hot sulfidation? So first is the major contributing factors for the sulfidation are chemical composition of the metal, means what is the uh, which metal we are using, whether it is carbon steel, stainless steel. So then temperature we have seen 230 and above, we can see this corrosion to occur, and this corrosion increase drastically at temperature about 260. Then the concentration of corrosive reactive sulfur compound. What is the concentration of sulfur compound, partial pressure and all. So that's also a critical factor. And third was the flow condition. Flow condition, if the flow is more, then the iron sulfide layer will get erode away easily. Now chromium content is a critical thing here, as we increase the chromium content, the the corrosion resistant will increase drastically. So like this 300 series are highly resistant to the high temperature sulfidation. So 304, 316, 347 are more resistant. So here we can see the modified curve. This is a very critical curve for the selection of the material in hot sulfur environment. So you can see here this side is a corrosion rate in mils per year, and this side is a temperature in Fahrenheit. So first, the corrosion rates are very high for carbon steel. This is the chart for the carbon steel. As the rates corrosion rate are very high, and as the temperature increase, the corrosion rate also get increased. Then when we increase the chromium, the corrosion rate will decrease drastically and material become corrosion resistant. So we are increasing chromium from 1 to 3, 4 to 6, 7, 9 and 12. So up to 12, these are the alloy steels. Then we start the stainless steel series, SS series. So carbon steel and alloy steel having very high corrosion rate, uh, and the corrosion rate increases drastically as the temperature increase. Now the stainless steel also at higher temperature having higher corrosion rate, we can see, but these are immune and better than the carbon steel. Now most critical things come the silicon content. The carbon steel with silicon content less than 0.01 having very high sulfidation corrosion. So when we have a service where we are using carbon steel, and then we have to be aware about the silicon content which should be more than the 0.1% to avoid the sulfidation. And the temperature we have already discussed. Uh, the metal temperature above 230 cause the sulfidation, but normally it become a concern above the temperature of 260 degrees centigrade. Okay, now what are the mitigation? This is not the naphthenic acid, this is sulfidation. Then what are the prevention and mitigation? First is material selection. So we have to select the more chromium content materials which having higher chromium, and then higher silicon greater than 0.1 percentage. Then the aluminum diffusion treatment. Sometimes we do aluminization. We put the aluminum coating on our internal piping to avoid the diffusion of sulfur compound into our metal. So this is also a solution. Then low nickel content at the temperature above 645, the sulfidation of high nickel uh, will be higher, so we have to select the low nickel content at higher temperature. So you can see the photograph of this here, the thinning of the piping. You can basically see the thinning which has happened due to sulfidation. Now this is a case study of FCC plant of the uh, FCC plant piping in the main column bottoms. So here this is the carbon steel piping, and accelerated corrosion has happened only in this segment. And when this segment was further analyzed, the silicon was found very less in comparison to other segment of the piping. So here there was a flow, and this is bypass bypass line where there was normally no flow. Now the flow rate is going like this. Here you can see this segment which having the sulfur silicon very less has got very drastic corrosion, and this has got damaged. But other segments having significant amount of thickness, remaining thickness, and that doesn't cause any corrosion. So we can understand from here the importance of the silicon in our piping. If we are using carbon steel, then we have to be aware that the silicon content should be higher. Now, the affected units in the refinery. This is the locations where the hot sulfidation occurs in refinery. Although this sulfidation occurs in all the units of the refinery from crude to coker, F- and this is I have highlighted for FCC. And so in FCC plant we can see here the stripper tower bottom we can see here. There are chances of sulfidation. Then this is a main column bottom. Then it's there in exchangers, fractionator bottom, main column bottom. Here there are chances of hot sulfidation. Inside streams also having hot sulfidation. Now the FCC feed is coming to preheater. Preheater also having the chances of sulfidation. We can see here where the preheater feed line nozzle. There is also a chances of sulfidation. Then riser, then the regenerator top also, and reactor cyclones also having the chances of the hot sulfidation. So these are the affected locations of the this. So hope you enjoyed this case study. Uh, we will come with another lecture series. So thank you very much.